All right, for this first example, we have a 24.5 centimeter radius pulley, and it is attached to a rope. The pulley is rotated through an angle of 70 degrees. And now the question is, how far did the rope pull when the pulley was rotated that far, or that through that angle? Okay, so how far is the rope pulled? Okay, in other words, how high was the weight lifted, I suppose. And so that's through an angle of 70 degrees. So we can utilize, the idea here is if you rotate the pulley 70 degrees, the rope is pulled a distance equal to the arc length of that rotation, because the rope is being pulled along the arc of the circle. Okay, so we're looking for an arc length situation. We're trying to solve an arc length. So we know that S equals R theta. I've got my formulas up here for arc length and area. S equals R theta. I have the radius is 24.5 centimeters. The angle theta I need to convert. Remember, this formula only works when theta is in radians, not degrees. So I've got to convert that. So I know that 70 degrees, if I want to convert that, I need a little more space. Oops. 70 degrees converted, I convert that by multiplying by pi over 180. Okay, if you remember our unit analysis from a previous video. And so my degrees will cancel. I need to reduce the 70 over 180. Well, I can divide them both by 10. They're both multiples of 10. When I divide them both by 10, the zeros essentially drop out. And so what I'm left with is 7 pi over 18 radians. Okay, so 7 pi over 18 radians. Okay, so now I have my arc length S is equal to the radius, which is 24.5, multiplied by my angle theta, which is 7 pi over 18. Okay. Now I'm going to go ahead and just punch this in the calculator. We're getting an approximate value here, and we're going to round this off maybe to the nearest. I should probably go to the nearest tenth, because I've got the centimeters measured in tenths tenths of a centimeter. So I want to keep the same significant figures there. So I'm going to go ahead and punch that in the calculator. I'm going to go 24.5 times 7 pi divided by 18. And I'm going to get approximately 29.9 centimeters. Okay, so approximately 29.9 centimeters. So it's just over one radius, actually, right? Radius is 24.5. So this is just going past that. So essentially a 70-degree angle is a little more than 1 radian. If you remember our discussion of radians from a previous video as well. Okay, so 29.9 centimeters is how far, so almost 30 centimeters this is being lifted off the ground or whatever it is. That's how far the object is being moved.